Welcome to CHANDRAS Edu. This is another video in the Embedded System Design course, and we are in the Unit 4. It is real-time based embedded system design, and we are discussing the topic task scheduling. In the task scheduling, we have different types of scheduling algorithms. That is, one is cooperative, and we have non-preemptive, and another one is the preemptive. So among these three, we'll be discussing about the non-preemptive scheduling, and in the non-preemptive, we will be discussing about the FCFS scheduling. That is first come first serve scheduling. So coming to the other schedulings, that is cooperative scheduling means the process has to cooperate among themselves to execute properly. So that is cooperative scheduling. Preemptive scheduling means, so currently if one process is executing, if other process of more importance came and it need to be executed first, then whatever the currently executing process will be temporarily stopped, and the process CPU time will be given to the process, other process which requires importance. So that is called as a preemption. So that is the preemptive scheduling. Coming to the non-preemptive scheduling, so it is also similar to cooperative, but the process will be giving the CPU time if its process is complete, if its process execution is complete, or if the process is requiring some IO response, then also it will give the CPU time to the other process. So that is a difference between cooperative and the non-preemptive. In cooperative, the process has to depend upon the other process which is currently executing, and in the non-preemptive scheduling, the process will be giving the service whenever it is not using the CPU time. And first we will be discussing about the first come first serve scheduling. So it can be also called as FIFO scheduling, that is first in first out scheduling. And as the name indicates, it the first entered process will be serviced first. Whichever comes first, the CPU time will be given to that. So the process which are entering into the execution or requires execution, they will be entering into the ready queue, and they will be stored in the order as they enter, that is in the order in which they enters. So the CPU time will be allocated, whichever enters first, so that will be allocated first the CPU time. It is generally like a queue which we stand for getting the ticket at the theater. So whoever standing first in the queue, so that person will be getting the first ticket. Like that, the first come first serve scheduling works. So there are some drawbacks also in this one. It favors monopoly of the process. Monopoly of the process means, suppose we have first process, so it will be getting the most of the chance. So whichever comes late, so they will be losing the chance of getting the CPU time, or they will be getting the CPU time very lately. So which does not, a process which does not contain any IO operation, any IO operation, so continues its execution until it finishes its task. Suppose if you have a process and it does not have any IO operation. That means suppose if we require a response from a keyboard, so that is an IO operation. And if it does not have any such operations, so that process will be executing until its completion. So that is the disadvantage. And also it favors CPU bound process, and IO bound process may have to IO bound process may have to wait until the completion of CPU bound process. Suppose if we have two processes P1 and P2, and P1 is a CPU bound process, and P2 is nothing but IO bound process. IO bound process is nothing but the one which has most of the time IO operation, something like a printer. So where it just requires the printing device access. so only CPU may be required at the starting time. Later the operation will be done by the printer itself. So that is some IO process. And if we take a CPU bound process, it requires most of the time the CPU time itself. Suppose the P1 has entered into the ready queue first, so which is a CPU bound process, then it will be consuming most of the CPU time. But whichever is P2, which only requires a small amount of the CPU time, it will be getting very lately. So that is the disadvantage, which leads to the poor device utilization, which leads to the poor device utilization. And one more thing is that the average waiting time here will be not minimal, will be not minimal. Why? Because the same example which we discussed, where P1 entered first, that is CPU bound, and P2 entered lately, that is IO bound process. So P1 CPU bound, it will be consuming most of the time, and P2 has to wait for a longer time, so that the waiting time is not less or not minimum in the FCFS scheduling algorithm. So for properly understanding this, we will take up a problem, so which has three processes, which are P1, P2 and P3, and the completion time for P1 is 10 milliseconds, and P2 is 5 milliseconds, and P3 is 7 milliseconds, and they entered into the ready queue together. Even though we say that they are entered into ready queue together, but first P1 enters, then P2 enters, then P3 enters. We are saying all of them together in the order, P1, P2, P3. That means P1 entered into the ready queue first, then P2, and then P3. So as P1 entered into the ready queue first, so P1 will be getting the first chance for execution, then P2, and then the P3. So we need to calculate here the waiting time for the process, and also turnaround time. Turnaround time is nothing but how much time it is taking from the time which entered into the ready queue till its completion of the execution. And also find out average waiting time and average turnaround time. And here we are thinking that there is no IO waiting for the process. That means all the three processes will be considering it to be the CPU bound process itself, or the process which does not have any IO operation. So for finding out these values, first we need to draw the table, draw the chart, which includes the sequence of the process, as well as the times at which they entered and how much time they have consumed. So this is the one, the in the form of a block we have drawn. The first entered is nothing but at 0, which is P1, and how much time it is taking for its completion is nothing but 10 milliseconds, as it's mentioned in the problem, and that is what 10 mentioned here also. So that is at the 10th millisecond, P2 will be getting the chance, and as P2 requires 5 milliseconds, it will complete its execution in 15 millisecond. Then P3 will be getting the chance of its execution, which consumes 7 millisecond, and it will be completing its execution 15 plus 7, that is 22 millisecond. If we draw this, the calculation of the values will become very easy. As P1 entered first, there is no waiting time for the P1. That is, P1 waiting time is nothing but 0. Next, we need to calculate the values for P1, P2, P3 waiting time, as well as the turnaround time. So waiting time for P1, so as it started first, and there is no waiting in the ready queue, it is nothing but 0 millisecond. So waiting time for P2, even though we are saying that P1, P2, P3 entered together, but in the order P1, P2, P3, so P2 has to wait until completion of the P1, so which is nothing but 10 milliseconds. And later P3 entered, so waiting time for P3 is 15. Why? Because it has to wait until the completion of P1 and P2. So P1 completion time is 10 and P2 completion time is 5. So total 15 milliseconds it has to wait. So average waiting time we can calculate just by taking waiting times of the three process by the number of process, that is nothing but 3. So on adding this 0 plus 10 plus 15 by 3, so which will be giving 8.33 millisecond. And coming to the turnaround time, first process, that is P1, which is 10 milliseconds. Why? Because there is no waiting time, and turnaround time can be calculated by time spent in the ready queue plus execution time. So for P1, ready queue waiting is nothing but 0 and execution time is 10 milliseconds. So totally 10 milliseconds itself. So when you take turnaround time for P2, it takes 10 milliseconds in the waiting in the ready queue, and execution is nothing but 5 milliseconds. So 10 plus 5, 15 milliseconds. 10 is waiting time and 5 is the execution time, so 15 milliseconds. Coming to the turnaround time of P3, so it has to wait 15 milliseconds, that is completion of P1 and P2, that is P1 10 and P2 5. So 15 milliseconds it has to wait in the ready queue, and 7 milliseconds it's time for execution. So 15 plus 7, 22 milliseconds. Similarly, average turnaround time we can calculate by taking sum of all the three turnaround times and by number of process, that is 3. So turnaround time of P1, P2, P3 by 3, which is 10 plus 15 plus 22 by 3, which is 15.66 milliseconds. So as we can see here, the turnaround time, if we take, we can calculate it as average waiting time plus average execution time. We can calculate the average turnaround time by taking average waiting time plus average execution time. So why? Because turnaround time is nothing but the waiting time plus waiting time in the ready queue plus execution time. So we can see it here. Average execution time is nothing but time taken for execution of the P1, P2, P3 by number of process. That is for P1 it is 10 millisecond, for P2 it is 5 millisecond, and for P3 it is 7. So 10 plus 5 plus 7 by 3, which is 7.33 millisecond. So average turnaround time, as we discussed, average waiting time plus average execution time. So average waiting time is 8.33 millisecond, and average execution time is nothing but 7.33 milliseconds. So total comes to 15.66 milliseconds, so which we calculated by taking this average also. So this is how the execution for the non-preemptive scheduling FCFS happens. So in the next video we'll be discussing about the LCFS, that is last come first serve. Thank you. And subscribe to the CHANDRAS Edu, and also log on to the chandrasekhar.com to get more content on the embedded system design.